Hello class. Previously we looked at the work done on an object and noted that the work changes an object's speed. Equivalently, when work is done on an object, it in fact changes the object's energy, the kinetic energy, which depends on both the mass of the object and the speed squared. Kinetic energy is often symbolically noted as either an EK or a K, so you'll see me use both of those notations. Let's look at some numbers. Let's say a hefty 100-kilogram football player is running at 8 meters per second. For the sprinters out there, that's about 12.5 seconds for the 100-meter dash, so not bad. This corresponds to a kinetic energy of 3.2 kilojoules. On the other hand, a bullet that is 10,000 times smaller, that's 1 times 10 to the 4, and only 100 times faster, 10 to the 2, will have the same kinetic energy. Because remember, the speed is squared. To understand work better, let's next consider the force being applied to move an object. Recall that for a constant force, or in other words a constant acceleration, we had this kinematics relation between velocity and displacement. After solving for acceleration and substituting into Newton's second law, we can rework to solve for the product between the displacement and the net force causing that displacement. In other words, the work. Notice that the terms on the right can be recognized as the initial and the final kinetic energies. Because I've brought mass in here, I multiplied by the acceleration from above, which involved my velocities, and so I end up with a term that is 1/2 mv squared, involving the final velocity and the initial velocity. And so this gives us an expression called the work energy theorem. This tells us that the total work done on an object by all the forces acting on it, in other words, the net force, equals the change in the object's kinetic energy. This work is positive if the speed increases, and so if the final kinetic energy is greater than the initial kinetic energy. And the work is negative if the speed decreases, so if the final kinetic energy is less than the initial kinetic energy. And this is consistent with what we learned earlier. Work is positive when we have an increasing speed and negative when we have a decreasing speed.